This introductory video is about how we use numbers in physics class. Where do numbers come from typically in this class? Well, most of the time a number comes from some type of measurement. We use some kind of instrument to measure something, and so in this class, numbers are used all the time. Now, if you're worried about significant figures, I wouldn't worry too much about that. We don't, maybe we should, but we don't make a big deal about them. We just don't want you to abuse them. A big deal is in working with our numbers, numbers are going to have a symbol attached to them and a unit attached to them. The symbol, of course, tells you what the number is about. For example, in the famous formula E equals mc squared, E, M, and C are all symbols indicating energy, mass, and the speed of light. But every number typically is going to also have a unit associated with it, and that unit is going to depend on what instrument was used to measure it. So certainly inches, meters, joules, lumens, some you're familiar with and some you may not be familiar with, but those are called units. And you'll find out this year, we're always going to make a big deal about, make certain you include your units in your answers. Now, an area that's really kind of strange is that in this class, numbers are of two types. Some numbers are what we call a scalar, and others are called vectors. You probably had some of that in your math class. Scalars just have the number, what we call the magnitude or the size of the number, and vectors have both a number, but they also have a direction. Maybe an easy way to remember this is to use the idea of east. If you can attach the word east to a number appropriately, then it's a vector. For example, time, a second. You would never say 10 seconds east. That doesn't make any sense. So time is an example of a scalar. It just has a number but no direction. However, you could easily think about pushing something east or running east. And so those, because that's appropriate, those things like acceleration, velocity, displacement, forces, these are considered to be vectors. Now, these two types of numbers are handled very differently in this class. Scalars are quite simple to deal with. You just add them and subtract them, just like pretty much multiply them like you do any other number you've ever seen before. So kids love it when things are scalars. But vectors are more challenging because not only is there the number, but there is a direction. This example is a good one. You know, it says you walk two feet, stop, and then walk 2 more feet. How far are you from your starting point? Well, if you think about it, a lot of different answers here. Did you walk 2 feet forward, then 2 feet backward? Well, if that's the case, you're right where you started from. But maybe you walk 2 feet forward and then another 2 feet forward. Well, now you're 4 feet from where you started. But what if you walk 2 feet east and 2 feet south? Well, you're farther away than 2 feet away, but you're not as far as 4 feet away. And so something like that, you're going to need to use angles, and it turns out we're going to be using some trigonometry to solve that problem. So you'll find out we do some sine and cosine tangent stuff in this class. There are little things that that you remember with numbers. You can never add numbers into different units. The illustration 2 seconds and 6 minutes is not 8 of anything. When you multiply numbers together, whatever you do to the numbers, you do the same thing to the units. Or when you divide, same idea. Something that will come up this year that will be confusing at first is the purpose of the negative sign. Negative will not always mean subtraction in this course. Sometimes negative will indicate a direction, that the negative direction is the opposite of the positive direction. If positive is east, then negative would be west. If positive is up, then negative would be down. Obviously, we'll talk a lot more about that later when it becomes appropriate. Precision and accuracy are two ideas that you should have learned about in previous years. Just a quick review. Precision, I would say, depends on the kind of equipment you're using. A more precise piece of equipment might give you more decimal places. I tell kids you pay for precision. A more precise instrument costs more, but the point of paying more is that you get a little more sensitivity, and so sensitivity is an idea of precision. But the more precise your instrument is, because it's more expensive, let's say, the more repeatable your results are going to be. And so that's, a lot of kids know that precision has to do with repeatability, but that repeatability is probably tied to the fact that that machine is more sensitive. Accuracy is completely different. Accuracy has to do with how does an answer that you come up with compare to the correct answer, what is recognized as the correct answer. And there'll be a lot of times in this class where we do a lab, let's say, and the whole purpose is to find the correct answer. And so you may report your result as how close you were to the correct answer. And the way to do that is what we call the percent error. And we use this all year long. So go ahead and memorize this now, that the percent error, the easy way to remember it is it's the answer you got minus the answer you should have got, all divided by the answer you should have got, and then you multiply it by 100 so you can put the percent sign. Basic versus derived, what I'd call raw versus cooked. Sometimes in class you get a really basic value, and that's usually a measurement that you make with some type of instrument, maybe a stopwatch or a ruler. But then you might take that information, those numbers, and do something with it, maybe divide one number by another. Obviously taking a distance and dividing it by time, that gives you a velocity or a speed of some type. And so the big deal is with this is that you have to watch your units. And so you'll start seeing some pretty sophisticated looking units and pretty complicated looking units because maybe a lot of stuff has gone into that number. Now what can be challenging sometimes is I talk about honoring dead physicists. One of the things that was done many years ago was sometimes to honor a physicist, a measurement or a unit was named after him or her, and that can be, I mean, they're very familiar, but sometimes you don't know what's behind the name. For example, these three men here. The first one is Isaac Newton, which is a unit of force, which is actually a kilogram meter per second, but we call that a Newton. The joule is a unit of energy or work, and you'll notice that it has a Newton in it. It's a Newton meter. And then a power is actually a joule per second. So if you take a watt of power and break it down, there's a lot of little things, like kilogram, meters, and seconds are all built into that. So you have to always be aware that when a unit is named after somebody, you need to remember what are the units behind that name. And as always, a unit named after somebody is capitalized, whereas a unit that is not named after somebody is not capitalized.